All right, so there's this issue that's coming up in the Heroes and Monsters project. And what is the issue? So here, your setup might be different, but the student went ahead and added the objects into the map in the map class's constructor. And in the map class, she had this map that can store objects of type object in it. And then she initializes the map or sets it equal to, if she puts the objects into the map right here when she runs the constructor and creates the map object. Okay, whatever. You might have it set up here. You might have it doing that over here in static void main, right? So, but then the problem's still going to be the same. If we focus on this line of code here, what is the program doing? It's taking a hero object, right? Hero is a variable that can store objects of type hero. We've created a hero here and we stuck it into the variable. Here, we are trying to put a hero object into the map that can store object type objects. And then, so what you need to understand is that objects are the superclass of all classes in Java. So every class can find a grandparent named a capital object. Okay? And so the problem that's happening is that when she goes and runs, she runs this hero dot scene, right? So she wants to go ahead and set it to true, but it's saying this hero that's in the map doesn't have a scene instance variable. And you might have the same problem, but instead you're trying to run a method that's found in the hero class and it's not being able to be run. And so it's the same problem, and the problem is that the hero has been typecasted as type object. All right. And so what's happening here, there's auto boxing, which was talked about in the textbook. Normally auto boxing, well, what you've seen is auto boxing goes like this. If you have like double D and you're saying is equal to 5.56, right? Oh, I'm sorry, not 5.56, 5, right? This type of data is int, but we're sticking it into a variable that can contain objects of type capital double, right? So then what does the program do? It auto boxes the data. It takes this int and it transforms it into type double before putting it into this variable. So then if I went ahead and printed out D, it would print out 5.0. Okay. So that's the same thing that's happening here, except the auto boxing that's happening is that the hero type object is being transformed into type object before being stuck into the map. Now what you need to understand is object is a superclass in Java that basically has no methods, it has no instance variables that are useful, right? It's just like a dummy superclass in Java. So once this happens, the hero loses all of his unique instance variables and all his unique methods. So then when we're down here and you're trying to access the scene in the hero, well, this guy is no longer a hero. He is now type object. All right, so he lost all of his instance variables and he lost all of his methods. Now, if that's confusing to you, then it should go something like this. Let's say we have an animal class up here, right? The animal class has a child class called dog. And in the animal class, we have a name instance variable and we have two methods, a getter and a setter for name. Okay. Over here in dog, we have two instance variables, breed and collar. Like collar would be Boolean, like true or false, whether he has a collar or not. And then breed is whatever breed, like French bulldog or whatever it is. And then we have getters and setters for those two instance variables in the dog. Well, when dog is inheriting from animal, what does that mean? That means when I create an object of type dog, it's going to first create the instance variables found in animal and also the methods found in animal before creating the instance variables found in dog and the methods found in dog, and then finally returning that object that was created over to where you're creating the dog object. Right? So how is this helpful? It's helpful because it allows us to write shorter code. Like if I had a frog class and the frog inherited from animal, and if I had a dinosaur class and the dino class inherited from animal, then that means in all of these children classes I would not need to define I would not need to define these instance variables nor these methods, right? So it saves us time. What we're doing here is we're factoring out all of the common instance variables and methods from the children class into the superclass, and then we're having the child class extend the animal class, right? The frog class is going to extend the animal class. The dino class is going to extend the animal class. So that way we don't need to write define these instance variables and getters and setters and all these different methods in the children class. It saves us time. Okay, great. Well, what happens if I create a dog D and make it equal to new dog? Then I say animal A is equal to D, right? So when I create the dog object here and it's stored inside this D variable, well, I can have access to all of these instance variables in these methods. Not only that, but I can also have access to these instance variables in these methods because dog extends animal. So when I create the dog object, it first starts by creating these instance variables in these methods, adding these instance variables in these methods, and then finally returning the object that we're storing in the D variable. Okay, great. So if I'm here, I could say D dot get name. I could do this. It's available, right? But once I could do D dot get breed or whatever it is right here. Any of these methods down here. So then, but then once I do this, then things change because we're autoboxing. This variable contains type dog object, but we're sticking it into a variable that can only contain type animal objects. So it automatically typecasts or autoboxes the dog into type animal before sticking it into this variable. And that's possible because animal and dog are in the same family, right? If they were unrelated classes, we could not do this autoboxing. But since they're in the same hierarchy, they're in the same family, we can go ahead and do that. You can typecast type dog as type animal, and you can stuff it into this variable. Okay, great. But now we have a problem because you cannot say a dot get breed, which is a method that's defined in the dog class. You cannot do that. And why can't we do it? Because we typecasted the dog as animal before sticking it into this A variable. Right? The A variable is an animal type object. So what does that mean? That means we only have these instance variables and methods available to use in this A object. So this is not possible. All right. So now we're going back to our program over here, right? What is the problem? The problem is that we're taking this hero object and it's automatically typecasting it as type object before sticking it into the map. What does that do? That basically it strips the hero of all his unique instance variables and all his unique methods. And the object class has no instance variables and basically no methods. It's just like a dummy class. So basically we're stripping the hero of everything that makes him a hero before sticking him into the map, right? So then when we're down here and we're trying to access this scene instance variable of the hero, it does not have it because it has been stripped of all of his instance variables and his methods. All right. So that's the problem. How do we fix it? What you can do is you can check what it is. You could say if this object is instance of hero, and this is going to be true if the object that's in this location is a hero or was typecasted from being a hero. So in this case, it was typecasted from being a hero into an object. So this would return true here. This would return true. All right. And so once you do that, then you can go ahead and create a hero variable, and you could say hero h is equal to the object found in this location in the 2D array. What is this going to do? This is going to typecast the object, the hero that was typecast as type object, back into being a hero and sticking him into this h variable. And then we can go ahead and do h.scene equals true. So sticking objects into the map strips them of all of their identity. But then if we want to go ahead and turn them back into what they were, we need to check what it is. And once we find out what it is, we can typecast them back into being what it was. That brings back, this here brings back all of the instance variables and methods, and then we can access them. Right? I like to think of it as like Superman and Clark Kent. Right? Up here, we created a Superman. Right? When we do this, we are transforming him into Clark Kent. He's going into the phone booth and he's turning back into Clark Kent. He can't use his powers when he's in Clark Kent form, right? And then once we want to turn him back into Superman, we go ahead and first check that he is a Superman, and then we typecast him back into being a hero before using his unique instance variables and methods.